The challenge of military and civilian emergency responders alike is the need to rapidly assess and manage an emerging incident, especially in instances of grave public threat. As sensor technology emerges, it becomes more important for operators to be able to make sense of the overwhelming amount of data that could be available.
Currently, data that is available is not made accessible to first responder or community decision makers. This lack of a common operating picture for response is made more complicated in the likely event of a joint military and civilian response to a catastrophic event. Collecting, validating, fusing, and presenting sensor data to operators in command and control, as well as the field environment, is the goal of researchers within the Air Force Research Laboratory. The use of handheld devices and a trusted ad hoc sensors network in conjunction with live, virtual, and constructive gateway technology can help develop a usable picture of the field environment that can be exploited for all levels of command and control, as well as critical training. AFRL's outreach to the local academic and business community provides a one-of-a-kind opportunity to simulate real and virtual environments for the purpose of technology discovery and application.
When first responders arrive at the scene of an incident, it is critical for them to be able to size up the situation, identify immediate threats to the public and responders, and rapidly develop a tactical plan to mitigate the incident. In the case of potential terror or man-initiated incidents, the ability to determine the scope of the incident, the potential for additional secondary events, and the anticipated expansion of the incident is tantamount to saving lives. Although most first response agencies have access to devices that can measure a limited number of contaminants, these devices do not have the capacity to communicate the data to a central point or to connect to other sensor sources and therefore provide an overall picture. This intentional plane crash into the side of a simulated chemical storage facility is staged at Calamityville, a 54-acre training and exercise facility in Fairborn, Ohio, operated by Wright State University. The crash illustrates the problem faced by responders and the challenges of rapid information gathering and dissemination. First responders are consistently plagued by a limited field of vision and their lack of access to critical data. In this case, responders arrive at the scene without knowing the characteristics or lethality of the chemicals involved, the weather conditions that may affect the operation, and the populations threatened by the spreading plume. This lack of information places responders at grave risk and threatens to harm citizens who are not made aware of the growing problem. One solution to this problem is by arming the first responder with communications and sensor technology that can provide them with the means of receiving information as it is made known, and also with the means of capturing critical information and transmitting that data to the incident command post and EOC. Transmitting usable data and graphical images from the incident scene allows frontline commanders, in this case the initial incident command post, to quickly evaluate the problem being faced and deploy resources where most beneficial. Likewise, the ability to receive information, mapping, weather data, and other information from the Emergency Operations Center, or EOC, will better enable the incident commander to understand the environment and threats that may be outside of his or her situational awareness. Currently, few technologies exist that facilitate this type of information integration. Many local response agencies have access to cell-based laptop computers for the purpose of accessing internet information, as well as to receive computer-aided dispatch information. The ability for this technology to capture a wide array of data from many sources is limited and would not be available to the typical response agency. Another hindrance to this level of data integration is the limitations of handheld radio-to-radio technology, which is the most prevalent of communication methods employed in the first responder community. Technology-based tools, such as smartphones or similar devices, have been marginalized by public safety over durability concerns and lack of a reliable platform. Although the incident commander here has a slightly better view of the scene, he is still hampered by a narrow situational awareness. His proximity to the scene, however, provides an excellent vantage point to collect and communicate additional data for EOC decision makers. Information such as number and condition of victims, characteristics of the fire and progress in mitigation is important to provide to the upper-level decision makers. At the EOC, the best opportunity exists to understand the broad picture of the incident and to coordinate or fuse information. It is here that various data sources can be mined and exploited, even to the extent of leveraging informal social networks such as Twitter or Facebook to gain valuable information. The Air Force Research Laboratory's Layered Sensing Operations Center, or LSOC, and the Warfighter Readiness Training Research Division's Air Operations Center Laboratory provide the technical frameworks and methodologies to better understand the potential of the EOC in decision-making. Through the experimentation of live, virtual, and constructive integration, the EOC environment can be used as a unique and robust visualization theater for live, virtual, and constructively created situational injects. Through the computer modeling of the various structures at Calamityville, a blended experience can be generated. From an intelligence perspective, ad hoc sensors can provide information that can be of a predictive nature. By connecting the patchwork of data information together, command and control elements have the opportunity to predict events. In this case, the exploitation of accessible community sensors, such as traffic cameras, and the standoff capability of aircraft-based sensor platforms can provide officials with the opportunity to identify behaviors and actions that might indicate a secondary intentional incident, perhaps worse than the first. The environment shown here is the Joint Command Operations Research Environment, or JCOR, at the National Center for Medical Readiness. This mock EOC, in immediate proximity to the exercise grounds of Calamityville, provides a cost-effective means to test sensor integration in a controlled yet realistic setting. Also, JCOR can utilize the data collected as the platform for high-yield training, in this case, the training of the health and medical coordinator at the local EOC. In the plane crash scenario, the ability to be able to monitor and coordinate hospital evacuations, patient movement, and medical resources can be simulated within JCOR, combining actual patients, virtual mapping, and constructive patients or injects. The unique environment of Calamityville and JCOR provide an exciting setting to demonstrate the technologies and methodologies of the sensors integration for data fusion in operations and training project. By the continued utilization of this synergy, both civilian and military responders can learn and adapt to new ways of together dealing with a complex emergency and humanitarian event.
Recommend establishing a rescue group. Also, initial assessment indicates we have chemicals released on fire. Recommend that the exclusion zone be expanded.